Thank you for downloading this podcast in a whole series on IGCSE Physics. The next 34 episodes will equip you with the knowledge and skills needed to succeed in your Edexcel IGCSE exam.
This introductory episode introduces the topics of study, the key questions that each topic hopes to answer, and an overview of the skills you'll learn to tackle GCSE questions effectively.
Science wasn't always conducted the way it is today. We live in an age where theories about the world around us must be founded on hard evidence. It's difficult to picture a time when your wealth and status granted you permission to decide how our world operated, based on nothing more than intuition.
Thankfully, since the scientific revolution, and physicists such as Nicolaus Copernicus and Isaac Newton almost 500 years ago, science has been a discipline embedded in known facts. In order to establish a theory about the world around us, there must be irrefutable evidence from experiments and observations.
You might be wondering how physics differs from science in general. Biology concerns itself with the study of plants, animals and their bodily processes, and chemistry studies the nature of chemical substances and their interactions. Physics is the study of energy and matter, concerning the understanding of objects and processes from the very small to the very large. Everything from inside the smallest parts of the atom to the widest, farthest reaches of the universe is the business of physics. The New Zealander physicist Ernest Rutherford once famously said, "All science is either physics or stamp collecting."
Coming back to learning physics for a minute, it's often useful to understand how working physicists think. Often we encounter problems about the world around us, containing unknowns and some known truths. Using laws of physics that we know to be true, and applying certain mathematical equations, we can produce predictions and explanations of such problems. It's therefore important to think creatively, while working logically and communicating clearly. These are ways that you yourself, listening now, will use to tackle problems in an exam.
Now to discuss what exactly this series will cover. Over the next 34 episodes, you'll encounter 7 sections. These sections are as follows: forces and motion, electricity, waves, energy, states of matter, magnetism, and radioactivity. Each section comprises of between 2 and 6 chapters that explore each section in more detail.
Before a new section is begun, we review each stage of the podcasts with a chapter dedicated to summarising that section, a bit of exam practice, and providing you with model answers.
Before you begin listening to the chapters and get stuck into the material, it's worthwhile touching on the basics of problem solving and how physicists use fundamental physical quantities in their calculations.
First, as mentioned earlier, physicists are problem solvers. You must learn to think logically to break down a situation into chunks of information that will be useful to you. Once you have all the information you think you know, a good idea is to look at the physical equations you know, to see if any quantities match.
At every stage, it's good practice to check the original problem, to ensure you're going down the right path. If you can't seem to go any further with a problem, there will be an assumption you need to make, which is sometimes obvious, to simplify the problem. Otherwise, you may have made an error in your calculations.
Once you have your final answer, it's crucial you provide the relevant unit to communicate what you've found. Furthermore, if the answer is very small or very large, you may wish to put a prefix before the unit.
Let's take a look at an example. If a question asked you to find the distance from here to the Sun, your answer would be quite large, whichever unit of measurement you chose. The answer is 150 million kilometres. Now here we chose kilometres, which is representative of 1,000 metres. We could go even further and say the distance is 150 gigametres, but this is uncommon and would confuse most people. However, in some cases, such as the memory on your computer devices, giga is an appropriate prefix.
Similarly, prefixes can be useful for very small measurements, for example, the width of a human hair. Hairs on humans range between 10 and 180 micrometers. In other words, 10 to 180 millionths of a meter. The message to take away here is, check the prefixes before you start a problem and before you quote an answer. If you're ever stuck in an exam, there's a list of prefixes provided within the formulae list.
If this all seems too abstract, don't worry. Once you've tried testing your knowledge with a few problems, everything should make much more sense.
Finally, we'll briefly mention how you will be assessed at the end of your course. Double award science candidates sit one paper, known as Paper 1. Triple award students sit two papers, known as Paper 1 and Paper 2. Paper 1 is 2 hours long and contains 120 marks. These are spread over about 14 questions and contain material from the double award syllabus only. Every candidate sits this paper at the same time.
Triple award science candidates then sit their second paper, often at a later date. Paper 2 is 1 hour long and contains 60 marks. This will contain material from the triple award syllabus and is usually spread over about 8 questions.
That concludes the introduction to these podcasts on the IGCSE Physics course. Now that you're up to speed about what this physics is all about, what these podcasts will entail and how you'll be assessed, I think it's time to begin. The first chapter is on movement and position.